Greetings, welcome to this new video about nodal analysis or node voltage method. Solve the problem number 6. Let's consider this network consisting of two resistors labeled R1 through R2 as well as one independent current source IS. Additionally, we can observe a dependent source, especially a voltage controlled current source. The question now is to apply the nodal analysis to solve for Vx and to calculate the dissipated power in each resistor. Let's move on to the solution. Let's start first by labeling all the nodes in the circuit, and I will consider this node as node 1. After, I will assign the voltage Vx to this node. Next, I need to select a reference node in the circuits. The reference node is typically chosen as the node with the most connections or as the ground node. Let's now assign arbitrarily the currents in each branch, and I will consider I1 is the current through the resistor R1 and I2 is the current through the resistor R2. Next, we'll proceed to apply Kirchhoff's current law in each node. By applying Kirchhoff's current law at node 1, we can write IS is equal to I1 plus I2 plus 0.05 Vx. And according to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the currents can be determined by the following equations. I1 is equal to Vx minus 0 over R1 and I2 is equal to Vx over R2. By substituting now A and B in 1, we obtain Is is equal to Vx over R1 plus Vx over R2 plus 0.05 Vx. And by replacing the current and the resistors with their numerical values, we obtain 2 is equal to Vx over 60 plus Vx over 30 plus 0.05 Vx. And if we combine all the terms of this equation into a single denominator, we obtain the following equation. And if we continue simplifying this equation, we obtain 120 is equal to 6 Vx. That means Vx is equal to 120 over 6. We get Vx is equal to 20 volt. Now let's move on to calculate the dissipated power in each resistor. Let's start first with the dissipated power in the resistor R1 is equal to R1 I1 square. And we know according to Ohm's law that I1 is equal to Vx over R1. That means the dissipated power P1 is equal to R1 Vx over R1 square. We obtain finally P1 is equal to Vx square over R1. And if we replace Vx with its numerical value and R1 with its numerical value, we obtain P1 is equal to 6.67 watt. Let's move on now to the dissipated power in the resistor R2 is equal to R2 I2 square. I2 is equal to Vx over R2. That means P2 is equal to R2 Vx over R2 square. If we replace now Vx and R2 with their numerical values, we obtain P2 is equal to 13.33 watt. After completing the calculation, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here this is the independent current source IS, and this is the dependent source, a voltage controlled current source, and this is the resistor R1 and the resistor R2. I connect here a wattmeter in order to measure the dissipated power in the resistor R1, and I connect also here a wattmeter in order to measure the dissipated power in the resistor R2. And here I connect a voltmeter to measure the voltage across the resistor R2. Let's move on to analysis. This analysis calculate nodal voltage. We can see here that the dissipated power in the resistor R1 is equal to 6.67 watt, and the dissipated power across in the resistor R2 is equal to 13.33 watt. Upon completing the network simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about nodal analysis. Take care and bye bye.